I am Ahmed Daud, and in this session, we are going to see an example of solving classification problem by using card algorithm. We will use the process same as sklearn has implemented, so that you will, whenever we have to code, we actually have to use the classes of scikit-learn. So to get the similarity between the theoretical part and the practical part, I will follow the same way like sklearn has implemented. So if some of you are having any confusion in the part how the decision tree is built over the training data, how the decision rules can be drawn from the data. If some of you are having confusion, you will get clear by this example. So in this particular example, I am using very simple data set in which there are two independent variables, GP and studied, and one target variable which is passed. In the GPA, there are three categories: low, medium, high. In the studied, there are two categories or values, you can say yes and no. And in the target variable, we have two classes, pass or fail. Now, GPA column, you can say that it's a ordinal qualitative attribute, while studied, you can say it's a binary attribute, and for the past, it's a target variable which has two classes. So this is the case of binary classification problem. Okay, so we will first convert our categorical data into numerical form. The reason is that because of sklearn does not support categorical independent variables for now. So whenever we have to feed our data to sklearn decision tree, we have to convert first our categorical variables into numerical variables. Like I said, there is always a gap between theoretical and practical part. So in the theoretical part, card algorithm actually can handle categorical variables, but in the practical implementation by sklearn, it does not support. Okay, so first of all, we have to convert our categorical variables into subnumerical form. Okay, but in case of past, which is our target variable, we can pass as it is. We don't need to convert it into numerical form, but I am doing here also. Okay, so as GPA is ordinal, so I have replaced low with 1 numerical value, medium with 2, and high is equal to 3 to maintain the order, and studied as a binary. So no means 0 and yes means 1, and passed fail class refer to 0 and pass class refer to 1. Okay, now our aim is to build a decision tree by using that data set and follow the way like we studied. We have to use some impurity measure. Probably, of course, we will use here Gini impurity to build a decision tree, and we will check against each value of our independent variable, where we should split our data set so that we will decrease our Gini impurity. Okay, so if we will plot a scatter plot, it will be quite easy for you to draw decision boundaries here. Let's say you will draw decision boundary here, and you will say the person who has studied will must pass the course. Okay, orange is denoting pass, and blue is denoting here fail. And then you can draw boundary here at the 2.5, and you can say the person who has not studied but have GPA high will pass, and who have low or medium GPA and has not studied will fail. Okay, so like drawing a decision boundary is quite easy here, but our aim is not to draw these type of boundaries. Our aim is to build a decision tree like this one. Okay, So this type of decision tree we will try to here build, and there are a lot of information here in each node, and you will get an idea about this information also. Okay. So first of all, studied, it has selected studied column and value 0.5 as the best split value among all of the values. Gini impurity of our target column, which is having these values at the very start, has 0.444 gene impurity. There are 6 samples in our whole data set. Value means value have 2 and 4. So at 0th index there is a 2, and at the 1st index there is 4. So it means 2 samples belonging to 0 class and 4 samples belonging to 1 class, and you can see here. Class is equal to pass. It actually uh, labeled as class is equal to pass on the base of majority of the samples. Like here majority of the samples are 4. So that's why here class is equal to pass. Okay. Again, when it is split into subparts, okay, on the basis of studied is equal to less than or equal to 0.5, this will be if this rule is false, then on the left side, and sorry, right side, and if this rule is will be true, then on the left side. On the right side you can see that who has studied, the students who have studied, they will be pass. There are 3 samples belonging to that category, and gene impurity will be 0 at when we have this type of data set. Okay, when we split in this way. So this type of boundary we will try to build, and the algorithm that we will use will be recursive partitioning algorithm. Okay, so it's a internal structure of CART algorithm. CART algorithm use recursive partitioning algorithm to build a decision tree. Okay, our aim is to build a decision tree. We are using CART algorithm, and in the CART algorithm, the further algorithm that actually build a decision tree is called recursive partitioning. So this is a purely theoretical part, and you will more get good idea when we will do example, and we will come back at the end, and we will try to see these steps here. Okay, so first we have to build a decision tree manually. Okay, so first of all, as I told you, first of all we have to calculate the gene impurity of our target column. Okay, we always calculate the gene impurity of the target column, but previously at the start we have all the samples, so we will calculate the gene impurity for our target column. So here probability of belonging to class 0, there are 2 samples, so 2 out of 6 will be probability of class 0, and 4 out of 6 will be the probability of class is equal to 1. Okay, so gene impurity, by using the same formula we get here gene impurity 0.44. Okay, so at the very start we have a gene impurity of our data set or our target variable 0.44. Now, now we are going to see what will be the best split. Okay, so here in the GPA case there are 3 values, 1 2 3. In the studied case we have 2 values. And how CART algorithm by sklearn actually use the process, like if you have to split let's say 0 the variable like a binary variable in which there are 2 values, so it actually calculate split in the in mid of both of them. Okay, it actually calculate the mean and max, and on the base of at each particular value, let's say in the case of studied column we have 2 values, so there will be one threshold or one split value is present here, which will be a 0.5. Okay, we can say the values less than 0.5 will be 0 value, and greater than 0.5 will be 1 value. In the case of GPA we have 3 values, 1 2 3. So how it will split, there will be 2 split points at one will be 1.5 and one will be 2.5. Okay, the values Less than 1.5 will be 1, and greater than 1.5 will be 2 and 3. In the same way, the values less than 2.5 will be 1, 2, and values greater than 2.5 will be 3. Okay, in this way. Why it is taking a midpoint? The reason is that so that we can able to solve the binary variables also, or we can get a split value or threshold for the binary variables. Okay, so that's why to follow the same process, it actually use that technique of midpoint. Okay, but the aim or goal is the same, and we will get the same type of result. So, as I told you in the start, we will calculate the Gini impurity of our target variable, which is 0.44 we have calculated. Now we will first explore our GPA column here. So, in the case of GPA column, we will have two possible split values. I am saying the split values that are the possible, you can say, where we can split our data set. Okay, the possible number of thresholds, you can say, or you can say split values where we are splitting our data set. Okay, like you can split on the base of GPA at this point your data set, you can split your data set at this point. Okay, in 2 points you can split. Now we will check the Gini impurity in both cases, as we have just two split values in the case of GPA. So we will check the Gini impurity against two split values. So let's say if we will split our data set on the basis of split value 1.5, so GPA less than equal to 1.5 will be this data set. This data set have all the values belonging to GPA is equal to 1, which is less than 1.5, and this is the false condition, or the you can say this is the left side is false, not holding that role, means these have GPA greater than 1.5. So all the values here is GPA is equal to 2 or 3 greater than 1.5. Okay, now we will calculate the Gini impurity of this child and Gini impurity of this child. Okay, so Gini impurity of the left child is 0.5, and denoting that it is very impure, that equal number of zeros and ones are present here. Now we will see the Gini impurity of the right child, which has 0 and 3 number of ones, 1 0 and 3 number of ones. So Gini impurity should be less than 0.5 here, and you can see here Gini impurity of right child 0.375. When we will calculate the weighted sum is like 0.5 into there are 2 samples in the left child out of 6 samples plus 0.375 into there are 4 samples in the right child out of 6 samples. So this is actually the weighted sum. So weighted sum is equal to 0.412. Or you can say when we will split our data set on the basis of GPA, and on the basis of GPA and split value 1.5, we will have a Gini impurity 0.42. And when we will split on the base of 2.5, then we will have these two data sets, and we will calculate the left child impurity, right child impurity, and the weighted sum of both childs, which is 0.33. So in the case of GPA, comparing all of the like there are two possible split values. So out of these two possible split values, there is one split value 2.5 which has less Gini impurity compared to the other split value. So we will select that split value best in case of GPA column. Okay, because it has 0.33 which is less than 0.42. Okay, so in the case of GPA, there is best split value is 2.5. Now we will check the best split value against the studied column. As studied column just have two values, so there will be one possible split value. So we will check the Gini impurity against that. So studied column, in the studied column, if we split at the value 0.5, then we have this left child and this right child. Okay, we will calculate the gene purity of both childs. So we have 0.44 gene purity of left child and right child have 0. So overall gene purity is 0.22. So as there is one possible split value in the studied column, so studied column have 0.22 gene purity at the split value 0.5. So comparing both of, like, the best split value of the GPA column is 0.33 and best split value of studied column is 0.22. So which is less? Of course, studied column has best split value 0.5 and has less gene impurity compared to the best compared to the gene impurity of the best split value of GPA column. Okay, so we will select studied column at the split value 0.5 as our first rule, as our root node. Okay, so as studied has less gene impurity out of all independent variables, so we will split with respect to studied. So now we have splitted our data set after comparing all other thresholds into again with respect to studied column into two childs. Okay, this will be left and this will be right. Okay, now these data sets, again we will follow the same process on these two data sets. So in the case of right data set, you can see here all samples belong to one class, means this if we will calculate the gene purity, so probability of belonging class 0 is 0, probability of belonging class 1 is equal to 1. So if we will calculate the gene purity is 0 here. So this is already pure, we don't need to further split that right child. The reason is that it's already pure, and our aim is to split our data set to get the homogeneous data points. Okay, to get the homogeneous group of data points. So we don't need to do further partitioning on the right side, but we have to do further partitioning on the left side because there is not fully pure data points we have. There is two samples belonging to 0 class and one sample is belonging to 1 class. Now again we have two columns, GPA and studied. So in the case of GPA we again have three values, means we have two possible thresholds here, 1.5 and 2.5 in case of GPA. But in the case of studied column we have just one type of values, which is 0, 0, 0. It means it has no valid partition or it has no valid threshold. So that's why we will not check the values of study, we will just check the value of GPA. And in the case of GPA there are two possible thresholds, 1.5 and 2.5. So we will compare against the GPA 1.5 and GPA 2.5 values, and we will select the value that has minimum gene impurity. Okay, so first, like we did in the case of in the start, first we have to calculate the gene impurity of our the data set. Now here the data set is this one, this one, this one is the data set. So the gene impurity of this data set will be can be calculated here. Like probability of class 0 is 2 over 3 and probability of class 1 is equal to 1 over 3, and again we have gene impurity 0.44 here at this side, at the left side. Now we have to decrease this gene impurity. Okay, so now in the case of 1.5 we have 1 point on the left side and 2 points on the right side. And when we will calculate the gene impurities of left and right child and calculate the weighted sum, it is giving us 0.3. When we select a GPU value 2.5 and based on this value we will split our GPA, our whole data set, then we are having 2 points on the left side and 1 point on the right side. And when we will calculate the gene impurity of both childs and do the weighted sum, we will get a gene impurity 0. Okay, so out of two possible values we have here, on the basis of where we can split our data set, and out of those two, there is a GPA 2.5 which split value which have less gene impurity out of all. So that's why now the split value will be 2.5, because it has gene impurity is equal to 0, which is less than compared to other valid partitions. So now we will split on the basis of split value 2.5 of GPA. Okay, so when we split GPA less than equal to 2.5, we have here 2 points belonging to 0 class, and on the right side we have 1 point only which is belonging to one class. So here you can see again we got a pure data points, and here again we get a pure data point. You can say that this right child again now have 0 gene impurity, and this left child have 0 gene impurity, because all of the data points belonging to the same class. Okay, so when we will if we want to see these all of that rules in the you can say in the way of simple rules without that data points, so we have this type of image. Studied less than is 0.5, and this will be of let's say if I will use another color here, let's say green one. So this will be a false case, and this will be a true case. This will be a true, this will be false. Okay, so if a person has studied less than 0.5 and have GPA less than 2.5, will be fail, and if have GPA greater than 2.5 will pass, and if a person have studied greater than 0.5 will pass. Now as these are not making some sense in the sense of you can say explaining the concept or explaining the data set, so I am converting this in the same way that we were having our original data set with categorical variables. Okay, like we are having a categorical variables, so it is explaining with respect to numerical variables. Now I want to see this in terms of categorical explanation. So now now you can simply say that a person who has studied, he will definitely will pass, and who has not studied, uh, further we have to check either he has GPA high, low or medium. If high, then again he will pass, or if he have low or medium GPA, then he will definitely will fail. So now we have built a decision tree on the data set that we are having. Now you can do prediction. Now whatever data point you will get, you will check the two rules: studied, yes or no, and GPA low, medium or high. Or in terms of numerical value, you can check the values you are in this way. Okay, so this is the whole process of building a decision tree. Now I will show you the theoretical part that I was saying, that recursive partitioning algorithm. It's actually the same that we did here, but now you will get a more pure idea. So let's say we have a one output variable and p number of independent variables or input variables, and we have a data set. Okay. So first of all, for each predictor, for each input variable, you have to see each value of that variable. Then you have to split your records with respect to each value, and measure the homogeneity of the classes. Okay, measure the gene impurity, you can say. Lower the gene impurity, higher the homogeneity. Then you have to select the value that produces maximum within partition homogeneity of class, like we did in the case of GPA. Second time we have selected 2.5 as our best value, because it is giving us the less gene impurity. Okay, so you have to do this for all cases, for all input variables. you have to pass one by one r input variables, then have to see each value of each input variable and calculate the your impurity measure and select the value that produce maximum partition homogeneity of class, like we did here. In the case of GPA, we have selected the best value is 2.5, and in the case of studied, as there was just one valid partition, so we were selected split value 0.5 here. Okay, so for each column you have to select the best split value. Now, when you have selected your best split value, you have to do partitions on that. Okay, now comes the recursive part. First, you have to initialize your data set, like you have the original data set, then apply the partitioning algorithm, like this is the partitioning algorithm. You have to partition your A data set into two sub partitions like A1 and A2. Then you have to repeat the whole process on A1 and A2. Again, A1 and A2 if produce further data sets and there is again chances of decreasing impurity, you again have to again partition until you will get uh, more pure your data points, or there is not sufficient improvement in the homogeneity of the partitions, or you can say there is no much decrease in gene impurity. Okay, you have to do splitting till the end, until you will get the pure data points or until there is no further improvement or decrease in gene impurity. Okay, you get the idea. First, you for each variable or for each value of each variable you have to calculate the gene impurity in simple words, and you have to select the value of the variable that have uh, less gene impurity compared to all other values of other input variables. Then you have to split on the base of that value your whole data set. Then again you have to repeat the same process. So this is actually the way of building a decision tree by using CART algorithm, and you also get the idea why CART algorithm is can produce only binary trees, because it's split into two parts on the basis of less than or greater than just one. Okay, and it like sklearn has implemented and does not support categorical variables, so you just have to first have to convert it into numerical form. Okay, so here you can see another example. We are having a iris dataset. Okay, we are having a iris dataset, and we build a decision tree um, by using sklearn, uh, and which iris has again two independent variables. Both are numerical values, and the species have three classes. This is target column, and you can see the decision tree. Here it is a decision tree. Like first it has splitted on the base of petal length less than 2.5, um, because it can give the best partition or best has lowest gene impurity compared to all other thresholds. So that's why they can have selected this one, and in this way they are growing the trees, the whole tree. Okay, there are some you can say keywords here, like recursive partitioning. You get an idea what is recursive partitioning. Recursive partitioning, that first you have splitted your data set into two partitions, or two data sets, or two sub data sets on the base of your best split value, which have less gene impurity compared to all other split values. So again you have to follow the same pattern on the splitted data set. Again you have to do partitioning. Again you have to decide the best split value and do partitioning. Again you have to select the best split value and do partitioning until you will reach till your endpoint. So this process of again following the same way, it actually called the recursive partitioning. Okay, like you see here the two three steps here. Like here you can see you have to select a you have to repeat this step number two every time when you have some data set, you have some sub partitions, and again you need to further split to reduce the gene impurity or some other impurity measure. So this is recursive partitioning. Recursively you are doing partitioning. Okay, and that's also the reason that usually call decision trees, the algorithm that we are following here, card algorithm, and do the greedy, or sometimes the people call as a greedy algorithm, because it is greedily such it is not seeing that after two or three splits what will be the result. It is just focusing on the present data set and or try to find out best split value and then do the splitting, and again it is doing keep on splitting. Okay, that's why it is also called greedy algorithm. Okay, so split value, you get an idea split value where we can partition our data set. Okay, like the possible split values in the GPU, there were two, 1.5 and 2.52 split values were there. What is node? Node is, you can say, each box here that can representing, or that is representing here some rule, less than, or these are the rules, some decision rules. So you can say here, uh, these are the nodes. Okay, so these are the nodes, this is also node, this is also node, and the end node, or you can say terminal nodes, are called as a leaf node. Okay, these are the leaf, and others, sometimes people call that these are the terminal nodes, and the decision, the nodes which are holding decision rules are called non-terminal nodes. Okay, and it is quite making sense that non-terminal nodes and terminal nodes. Impurity, you get an idea like Gini impurity. Impurity, we are calculating the how much impure our set of elements or our data points, or our group of data points, how much impure. Okay, if our group of data points have same type of data points, then we can say that it is fully pure. There is no impurity in that group of data set. And pruning you will see in coming sessions what is pruning, and we will do a lot of brainstorming on the pruning part also. So now we will have a look on the coding part, which will be quite easy. You will get the idea how easy to implement, and you are already familiar that by importing the models from some libraries, quite easy compared to learning the concepts. Okay, so in the coding part, it will be a quite easy, because we are going to use the same data set that we have used in the theoretical part. So first of all, I am importing here the extension NB-Black, and then some of important libraries, Pandas, Seaborn, PyPlot. Already you are familiar with these. And now this is just a new one for you, sklearn import tree. Okay, to import the decision tree from sklearn. So here I have my data set, and now I am converting my dictionary into data frame, where I have all of the variables as a object variable, or you can say all the variables have categories in it. Okay, so now I want to replace my categorical variables with some numerical values. So I am doing manually it by first designing the dictionary replace, and by using the method of data frame dot replace, and I am passing that dictionary to convert my categorical variable values into numerical form. Okay, now I am copying that into df2 so that I can use the df2 for further case. This is the scatterplot that I have shown you. I have separated x and as a x and y. My data set, y will be our target variable, which is named as past. Okay, so now here the classification tree dot decision tree classifier with the random state is equal to 1. So this is I'm using here, and you can see here decision tree classifier. from sklearn.tree, and these are a lot of parameters, or you can say hyperparameters. We will study these in the coming sessions also. But for now, I am importing from here. And the stuff that I was telling you, that able to handle, actually that algorithm can, cart algorithm can able to handle both numerical and categorical data, but scikit-learn implementation does not support categorical variables for now. Okay, so that's why we have converted first our categorical GP and study categories into some numerical form. Here we have built a decision tree by using the same fit method, and you can see that classes of that classifier has 0 and 1 because we have passed these, and features GP and study. So there is another library from sklearn.tree.plot tree that can help us to build or to see the decision tree that we have built. Okay, so we have built that decision tree classifier. So I am passing a classifier, then the feature names as I have passed into my classifier. Field means that I want to fill that boxes, font size 9, node IDs. I want to here node IDs, node number 0, 1, 4, 1, 2, 3, 4, these node IDs. Class names, fail and pass, I have manually pass here because my classes are 0 and 1 in my classifier. So here I have passed that 0 class should be fail and 1 class named as pass. Okay, so that I can see my decision tree and you can have a look. In this way you can see your decision tree what you have built. Okay, so for now this is just to give you an introduction of sklearn dot tree dot decision tree classifier, and in the further sessions we will have a more detailed look. But this whole session was for the case of how we can how the cart algorithm actually work, how the theoretical process. It's quite easy, and I hope you get much clear about this. Regression process is also the same type. Just we have to change our impure, instead of impurity measures, we have to use some other measures. Okay, so in the coming session we will have a look on the regression problems, and we will try to solve that by decision trees. Okay, so for now